two or more, later on in the year we'll study more, two or more equations together. When we're looking at the solution today, just today, because we only have two equations, the solution is going to be x, y, the whole thing, the ordered pair that makes both equations true. And I know already that algebraically or graphically, you've already showed me that you can find that on a graph. Okay, so we don't have to review that part, I don't think. We're going to talk about substitution and elimination. Do any of those words sound vaguely familiar to you? Okay, some of you came right from, you're doing Algebra 1 and Algebra 2 back to back, so that should probably ring a bell to those of you. We spent quite a bit of time doing this. So both of these are valid methods for solving. And I'll tell you when I usually use the one versus the other. So let's do an example of substitution. Thank you. First of all, to show that the system is together, we usually have a bracket or something like this, or either that or they're stacked right on top of one another. And this would be something along the lines of, thank you. Negative 2x plus 2y equals negative 6. And then x equals y plus 3. Okay. So typically in a situation where I use substitution, either one of the variables is already by itself, or you can really easily like move one thing to a side and have it be by itself. What variable am I talking about here? Say it louder. X. See how it's alone right here, okay? So what substitution is, it's just like substituting if you were playing in a volleyball game, okay? When you substitute in a volleyball game, doesn't somebody come out and somebody comes in their place, right? Okay, same idea. This x right here, I'm going to take out, and in its place, I'm going to put what x is equivalent to, because equals means it's the same thing. All right, so we're going to rewrite this top. This becomes negative 2. I'm going to put a parentheses there to hold my x. Okay, that's what I'm doing there. And what I'm going to do is put what x equals in its spot. And what does x equal? Y plus 3. Now, we keep going. So that was my substitution. Plus 2y equals negative 6. Now I have an equation that just has one variable. Would you continue and solve, please? I'll do it up here, but I'm going to let you do it. Okay, is this what you got? Now, in many of the cases that you see today, you're going to get y alone and you're going to get an answer. What happens here, though? These cancel. and we're left with -6 equals -6. Okay. Is that a true statement? Yep. This is what this means is this was the same line. We call these coinciding lines. On your worksheet, we'll do one that has an actual answer. Coincident lines, how many solutions do they have? Oh my gosh. Yes. I'm so excited that you knew that. Maybe you didn't know that. Maybe some of you didn't know that. I heard somebody knew it. But that means it's got infinite solutions because everything on the one line is also on the other line. Okay. Okay. Let's try to do one that has an elimination example. So you can see how elimination works. Am I going too fast? Okay. Now I have had some students like that will get to, for instance, pre-calculus, and they're like, oh, I use substitution all the time. They love substitution. They move everything around. They get a variable together and they want to use it. Personally, I prefer elimination when I can use it because I think elimination's easier. Here's what I will tell you. To me, substitution's pretty easy when the variable's alone. But when it's not alone and it requires a lot of work, elimination to me is easier. And the idea with elimination is we're going to multiply either one or both rows by something to eliminate one of the variables. Okay, so here's what I mean by that. Now, sometimes they're already, I'm going to give you an example of something that's already opposite. So let's say I had this one, -3x plus 3y equals 0, and 3x plus 9y equals -12. So let's say I had that. Okay, now, do you see how this -3x and 3x are opposite coefficients already? So if they're already opposite coefficients, we're going to just add them together. What if they're the same coefficient? Then just multiply one of your rows by -1 and add them together. Watch what happens. I can add these two rows together. I'm going to add down. And what's -3x to plus 3x? 0. That's that elimination. Eliminated. Okay. What's 3y plus 9y? 12y equals -12. All right, this one we can solve. Let's divide both sides by 12. Y equals -1. Okay, do you remember what I said up above? The solution is an ordered pair. I found the y. How am I going to find the x? Plug it back in. Does it matter which equation? No, because it should make both true. I'm going to plug it into the top. So -3x plus 3 times -1 equals 0. And I'm going to solve the resulting equation. Okay, so what are ways you can write your answer? You can just like circle both of those, or you can write them as an ordered pair if you want. This would be your solution. Is it coming back to some of you? Okay.